All right, welcome everybody to Halloween in C++. So we're going to talk about the spookiest part of C++. No, it's not pointers, it's exceptions. So, yeah, you recognize the background? I chose that one for Halloween. For those that know, for those that don't know, don't look it up. All right, so what we're going to talk about today is exceptions, and exceptions are something you've probably encountered from a little thing called string to integer, or STOI for short. So if you have a string s that's containing the numbers 45%, you have an integer x that is equal to STOI s. This converts a string to an integer. Does this work? Yes or no? Can you convert 45% to an integer? Anyone know? Vote now. Yeah, a lot of people think the answer is no. Let's try this out. Will it compile? Yes. Will it work? Yes. It only printed out 45 though, and the reason for that is because int x is an integer. Okay, and so when you call string to integer on something, it converts one character at a time. So the way that STOI works, one character at a time to an integer. If the first character is not a digit, it throws an exception, which is our topic for today. Otherwise, it continues until a non-digit is read or the end of line. Okay, so 45, 45, like that, with a percentage sign in the middle, is going to be just 45. Once it hits a non-digit character in the string, it stops and it just returns 45. Now, if we were to switch this around a little bit and made this percentage 45, this is going to do what? What is this going to do? Nothing? Actually, it throws an exception and it kills your program. And that is our topic for today. So for your, it does quit, but technically it doesn't quit the program. What it technically does is it throws an exception. So an exception is like a flare going up, okay? And so STOI is calling for help. Gondor, the beacons are lit. Gondor calls for aid, that kind of thing, right? And so when the flare goes up, if nobody catches that flare, if nobody catches the exception, if nobody pays attention to it, then it kills your program and it dies. And the thing prints terminate called after throwing an instance of stood invalid argument. What is STOI? Abort core dump. Okay. So we got a couple ways of handling this. Okay. There are two approaches you can take on your Pokemon assignment. And the reason why this matters for the Pokemon assignment is because some of the Pokemon moves have a hyphen in it. Okay? It's actually not a hyphen, it's something called an M dash, which is the longer hyphen you will see in Microsoft Word. If you try converting a hyphen from a string to an integer, it throws an exception and it kills your program. So you don't want to do that. So there's two ways of handling this. Okay? So there is the first way, two ways to handle a hyphen where you're expecting a number. Okay. First way, option number one, is check to see if the first digit is a first character is a digit. Okay. So if you do this approach, you say if is digit s dot at 0. Okay. In order to get is digit to work, you have to include CC type like that, and then we can do this just fine. And if the first character is not a digit, then we can see out s is not an integer. Okay, and this will work almost perfectly. Can you read in the first character and then just not use it? Well, if you read in just the first character of 12, you should probably use the 1, And so what you do is after you do your get line, you do your split, which is what we talked about last time. you need to tell if that column held a hyphen or if it held a number. And so by just looking at the first character of that string, you can tell if it is a valid number or not. And so if I run this right now, rather than dying, it will just print S is not an integer. And in fact, what you're going to do is when you're reading any moves that have a hyphen in it, you just throw them away. And so you're going to be in some sort of loop, and so you're going to hit like continue, right? Now this is going to yell at me because we're not in a loop right now, but basically for your assignment, you're going to be reading one line of the moves.txt file at a time. You're going to be reading in all the moves from the Pokemon moves file. And if any of those moves have a hyphen in them, you just throw it away. And you throw it away by just doing continue. It goes back up to the top of the loop, and it will go through again and read another line. If that one has a hyphen, it throws it away. And if it gets past all these checks without issues, then you do the pushback. You add the thing to the vector. So this is a perfectly valid approach. It works just fine in all cases except one. Alessandra, can you think of a problem with this? Where will this crash? If you try reading the first character of a string, when can that crash? This is a good habit of mine that all of you guys need to get into, which is like, when could this break? Mr. Mime? Nope, it'll work fine on Mr. Mime. The first character is an M. It'll be like, it's not an integer or whatever. But when do you have trouble reading the first character of a string? When there are no characters. Very good. So if we pass an empty string to it, which you'll get a lot when you do getLine, you get a different exception throw. So this time it's not Stoy that's causing the code to crash. It is the .at function. It said you're trying to read the first character from a string that has no characters. And so it throws an exception saying you tried reading index 0 out of a string of size 0. Not good. It throws an exception. We're not catching the exception. It kills the program. Okay. So we would need to add in a check like this, like if s.size and is digit like that, and then it will work fine. So this is saying if s.size, so 0 is false, right? So if s is false, then it doesn't do the rest of the and. Because C++ is smart, and this is actually part of the standard. If the first thing in there is false, it doesn't check the second thing and go out of bounds. So this is something called short circuit evaluation. And it's very nice. If you didn't do that, you'd have to have a separate if statement. So with this, we can say if string has at least one element in it, because remember, any non-zero number is true. And that thing is a digit, then we stoy it. Otherwise, we just print out it's not an integer. And this is good code. This is all you need for your homework assignment. But you might be wondering about all these exceptions and how you're supposed to handle them and stuff like that. How do you trap, when Gondor calls for aid, how do you trap that flare and do something with it? So what if you had an or? Or is not going to work because if you do that, then when you run it, it goes out of bounds. The reason for that is because s.size is 0, which is false. And so it's possible the whole thing is true by checking both sides. And so it'll check the right side here, and it checks that, and it goes out of bounds, and it kills the program. If you have an and, though, if you have a false, anything ended with false is false. So it does not need to check the right-hand side. It has to see what's on the right-hand side of the and to know if it's true or false. The whole thing is true or false. But if the first part here is false, size is 0, then it does not even look at the right-hand side. It doesn't even call the function. It doesn't call isDigit. It doesn't call s.at. It doesn't look at any of it. If s.size is 0, it stops. And it's like false. And it immediately jumps to the else block here. And it does not evaluate any of this stuff on the right-hand side over here, which is nice because it would crash if it did evaluate it. But it doesn't at all. It's not like it does it and then, no, it does not even call those functions. It's called short circuit evaluation. Very useful. Okay, so option 2. So we're going to comment out all this code. all this beautiful code we just wrote. I guess we can save this code. All right, let's just read it from the input. Read. Please enter a number or something. All right. So we'll read in a number or something. Might not be a number. And now I'm going to show you guys how to handle the exceptions being thrown. How do you catch an exception? So what you have to do is you have to put everything into what's called a try catch block. And that ... is not a typo. It is not a mistake. It is not shortcut. It is actually a legitimate C++ saying catch any exception thrown during the try block. So if I see out hello world like this, hello world does not throw an exception, so the catch block is not going to get called. Okay? So the try block runs normally. But if any exception is thrown during the try block, then it's going to come down here and print exception thrown. But it's not going to kill your program. So come in here, compile it. Hello world. Hello world, right? There's no exceptions being thrown by hello world. So let's try this now. So now we're going to call stoy. So the user is going to type in a number, which might not be a number after all. We're going to call stoy. We're going to call stoy on it. And then if that throws, it immediately stops running the try block. It jumps down to the catch block and it prints out exception thrown. Or in this case, we would be like, it's not a number. Okay. So we know what causes stoy to throw, right? It's pretty much only if it's not an integer. But if it is an integer, then it continues on, it prints out this, and it skips over the catch block. So the catch block only runs if an exception is thrown. Okay. Using our number, 122, we get 122. Type in that, not a number. Type in that, not a number. 123, and that, we get 123. Okay? So that is basically all you guys really need to know about exceptions for now. I'll give you a little bit more detail. Instead of ... you can do something like this. You can say like exception runtime error key, and that's going to require us to include std except, I think. And so if we throw a runtime error, then it's going to say say one thing. So sometimes sometimes things can throw different kinds of exceptions, and so you can catch individual exceptions and handle them separately. Runtime error occurred. Okay. And then this one, invalid argument to stoy. Well, that one we know. Not an integer. Okay. And then we could just do the ... after it and say some other D3W, some other error exception was thrown. Okay. If it's mixed with letters and numbers, remember the rule on how stoy works. Stoy will only throw if the first character in it is not a number. Once you've read a number, it will never throw. So this will return 1, 2, 3, 4. Stoy will convert 1, 2, 3, 4 GGG into 1, 2, 3, 4. But if we typed in here hyphen, we get non-integer because it throws an invalid argument exception. And if we did something like s.at 100, so that's going to be out of bounds probably, then we get some other exception was thrown, right? Because s.at throws an exception when you go out of bounds, and we catch it and we say, hey, some exception happened. Who knows? Okay. What if we did GGG 1, 2, 3, 4? Is the first character in this a number? So all stoy cares about is if the first digit is a number. If it's not, it will throw an exception. Okay. So there you go. Actually, some other exception was thrown. Really. I thought it was an invalid argument. Oh, stood out of... Oh, right. Because of this. This is the out of range error. Okay. Right. Catch out of range error. And then we can catch ... So you can have all sorts of catches, and you can pick up, the different errors that are thrown by different things like .at and stoy and things like that. So for example, the out of range error, it could be like s.at went out of range. And we can do this one. See, some other exception happened. Okay. And the ... will pick up everything. It'll pick up everything. Yeah. So basically, if an exception is thrown, it checks, is it a runtime error? Nope. Is it an invalid argument? Nope. Is it out of range? Nope. Okay, pick up all of them. And this will prevent your code from dying. Your code does not die after this point. s.at went out of range, right? And then we can keep going on down here. Cout, yo ho, a pirate's life for me, don't sue me, Disney. Okay. If we do this, then s.at went out of range, and then it continues on. It does not kill the program. If you catch the exception, it does not kill the program. Okay? That's the rule. Is it white space sensitive? That's a good question. All right, s.at. Let's get rid of view. No, it works fine. So that is exceptions, and you can and if you want to know how to throw an exception, you can do something like this. You can say like throw. You can even throw a number if you want. You can throw anything. Throw the number 42, and then it's going to print out the number 123, and then it throws 42, and it says some exception happened. So you can throw literally anything. Nobody does this though. Like nobody throws integers. That's so gauche and uncivilized. Instead, what we do is we like throw an exception. Blah. Let's throw a runtime error. I'm tired of this. Okay. And then you can see we threw a runtime error, so it picked up on the runtime error catch block. Do you guys understand what's going on here? So we call stoy. Stoy was successful. Cool. We print out 123, and then I throw a runtime error. And then because we have a catch block that specifically catches runtime errors, it jumps there and it prints out runtime error occurred. If you want to get more information on your exceptions, you can use what. Alexa, play Lil Jon What 10 hours. Oh wait, I don't have Alexa. Okay. So here we go. What? There we go. And so you can see it is printing out the error message. So when you throw an exception, you can pack an error message into the exception, and then you can get it out. It's like an if-else if. Exactly. That's exactly right. And so when you throw it, it checks this one first, then it checks this one, then it checks this one, then it checks that one. Okay. First one it matches on, that's what it prints. And so if you ever want to get the information packed within an exception, you can call what on it, and that will give you whatever error message is put in. So if we come back up here, put this back in, we can do this, and do this, and we cannot do it here. Why? Because we don't have an exception. It's just ... Remember, this will catch everything, including integers. There's no what on an integer. But any of the exception types have a what on them, and that will give you a little bit more information about what happened. So You can see that it's printing out the error message we put in there. It says a runtime error. Let's go ahead and get rid of that throw, because it doesn't make a whole lot of sense. Everything's fine. But if I pass in that, then the what is stoy. So basically, it throws this invalid argument exception, and for the error, the what, it just says stoy. You know, you're getting exception out of stoy. All right, cool. And so we know what that means. We know that means it's not an integer. Right? So this is easier than GDB. It is. Yeah. If you want to rethrow, then the rethrow will not get caught because we're already in the catch block. So we rethrow out of it, and then the program dies, right? So if you compile your code with debugging on .cc and run it inside of GDB, run. If you run it normally, then everything works fine. If you run it again and type in squirrel, then you can see that GDB will let you know where you were when you died, when that exception was thrown. So you can type backtrace, as always. Backtrace tells you which function was inside of which function. Right there, main.cc, line 35. That's where we died. Let's go up to 6, and we can switch into TUI mode with Control X, Control A. So that'll show you exactly the line that was thrown, that was not caught. That killed our program. Done. Okay. So if you're ever getting a death by exception and you don't know why or where it's being thrown from, GDB a.out, run the program. When it throws, then you can type backtrace. Again, backtrace will tell you I was in this function, which was called from this function, which was called from this function, which was called from this function. So main called a function called throw, and then that's going to call terminate, and so on and so forth. So that's the line of code that we were on when we died. Control X followed by Control A switches you into TUI mode. TUI mode is text user interface mode, and then you can actually kind of see some context. If you don't have that, then what happens is it just shows you the one line of context there, which, yeah. Or, more likely what you do is you just open up main.cc, then main.cc, line 35, and you can see exactly which line of code you're dying on. Okay, so that is, you need to spend more time with GDB. Yeah, everybody does. Like GDB, written by my boy Richard Stallman, my house guest. It is a complicated beast. It really is. But when you know like the basics at least of GDB, you can find instantly why your program is dying and then fix it. Sometimes scouting all the things is faster, sometimes GDB is faster. It just kind of depends. You need to get good at both of them though. Like really getting good at debugging is one of those absolutely essential skills every programmer needs. So for the homework assignment, you're going to be calling string to integer stoy on a lot of things, and it will be throwing exceptions if you're not checking to see if the first digit is valid. So you can either do it this way, like that. You can either do it that way, or this is option number 2, catch the exception. Right. Okay. And if you do that, then if you ever get a thing like that, you don't need to print an error message. Instead, what you do is just hit continue. And then it'll jump up and do another get line, and you're good to go. This is a solo project, so get good. It'll be due on Friday. I moved the deadline back because a lot of people have calculus midterms and essays due on Wednesday. So I am a generous God, to quote the 300. And I am giving you guys till Friday to do it instead. Get good. Yeah. So yeah, you're welcome. Yeah, it's 2 days, and a lot of students were not like. I was looking at Mint Corelli, and like, yeah, the tutorial center is going to be slammed tomorrow with this. So I want to talk to you guys about exceptions because I'm getting a lot of questions about those. So now I'm going to stop this recording, and I'm going to go work you guys through a real life example of like coding up something from scratch. So I'm going to stop this one now and start another video in a second.